Okay guys, today we're going to be learning how to derive the unit circle, and you really don't have any homework over this tonight except for to finish the unit circle completely and to practice. We are going to have a test over this whenever you get back to class next week, so make sure that you understand it. You will only have 40 minutes to complete it, and it'll be over the entire unit circle, 81 points. So let's start off and figure out how to derive this. So we learned a little bit about this previously, and it's basically all about conversion. It's remembering how to go from degrees to radians. And what we know are going to be these things right here. 0, 90, 180, 360. Those are the basis for what we know, okay? We know that 180 degrees is pi, so that means we're going to multiply that by 2 to give us 2 pi being 360. 180 divided by 2 is 90 to give us pi over 2, and we know that that's also 0 radians, okay? Now, we know all of that, so what we're going to do is we're going to go straight to our unit circle, and we're going to skip down here. We're going to skip this line for now, and we're going to go straight down here. And we are going to start doing our unit circle. So I'm kind of like a color-coded freak about this, and you don't have to be, but I have found that if I put and I do my unit circle in colors, it makes it so much easier for me to remember how they came about. Does that make sense? So I'm going to do my 90s and my 45s by simply going ahead and using one color, okay? So red. We have 0 here, and we have 180 degrees here. 180 divided by 2 is going to be 90. 90 divided by 2 is 45. So what we're going to simply do is go around the unit circle counting by 45 degrees. 45 plus 45 is 90, plus 45 is the middle one, gives me 135. Plus 45 is 180, plus 45 is going to be 225, if I can write the right number. Plus 45 gives me 270, plus 45 gives me 315, plus 45 gives me 360. Okay? So that is us doing just counting by 45 degrees. Okay, so now let's go ahead and do the same concept, but this time we're going to take 90 and divide it by 3. Why? Because I have 1, 2, 3 equal sections. So 90 divided by 3 is going to be 30. So let's continue counting around the circle by 30 degrees. 30 plus 30 is 60, plus 30 is going to be 90, plus 30 is going to give me 120, plus 30 is 150, plus 30 is 180, plus 30 is going to be 210, plus 30 is 240, plus 30, I need to write meter for you guys. Plus 30 is 270, plus 30 is 300, plus 30 is 330, okay? So now I've gone and got all of the degrees. Now I'm going to switch colors, and I'm going to go ahead and now I'm going to post in here, I'm going to do my radian measures. My radian measures, I'm going to do exactly the way I did before. I know that 180 is pi. I know that half of pi is pi over 2, and then I know half of that is going to be pi over 4. So now we're going to go around and count by quarters, okay? Super important that you understand it's by quarters. We did this once in class together, so now we're going to do this a second time. 1/4 plus 1/4 is 2/4. 2/4 reduces down to pi over 2. Our pi is going to stay as a variable in our radian measures. So 2 pi over 4 plus pi over 4 is 3 pi over 4. So keeping that in our hands, plus pi over 4 is 4 pi over 4. That reduces down to pi. Plus pi over 4 is 5 pi over 4. And again, I need to write meter for y'all. Plus pi over 4 is 6 pi over 4, which reduces down to 3 pi over 4. No, I lied. 3 pi over 2. Okay? Which then I'm going to add, that's the 6. I'm going to add another, and that's 7 pi over 4. And then lastly is going to be 8 pi over 4. Okay? So the next thing I'm going to make, this is going to be a whole 2 pi. Okay? So now what do I need to do? I need to then go ahead and I'm going to go around and count by 30s. Okay? Well, in order to get 30, I took 90 and divided it by 3. So pi over 2 times 1/3 is going to be pi over 6. So now I'm going to go around and count by pi over 6s. So pi over 6 plus pi over 6 is 2 pi over 6, which is going to reduce down to pi over 3. plus another pi over 6 is 3 pi over 6, and that reduces down to pi over 2, already have it. This is going to be 4 pi over 6, which reduces down to 2 pi over 3. Then 5 pi over 6, and then this is 6 pi over 6, which reduces 7 pi over 6, which then this becomes 8 pi over 6, which is 4 pi over 3, 9 pi over 6, which reduces to 3 pi over 2, 10 pi over 6, which is 5 pi over 4 over 3, and then lastly is 11 pi over 6 to give me then lastly 2 pi, okay? So now I've done all of my degrees, I've done all my radians. So the next thing we want to do is we want to talk about quadrants. Okay, well quadrants are super easy. This is quadrant 1, and this is positive, positive. This is quadrant 2, and this is going to be negative, positive. This is quadrant 3, and this is going to be negative, negative. And this is quadrant 4, and this is going to be positive, negative. Okay? I want you to have all those on there. All right, the next thing that is super easy for us to put on are going to be our decimal equivalents. So I'm going to go ahead and put my decimal equivalents on there. This is 0. Pi over 2 is the same thing as 1.57. Pi is the same thing as 3.14. 3 pi over 2 is the same thing as 4.71. And then this is going to be 6.28. Okay, so I've done my quadrants, I've done my decimals. Now what I want to do is put a little ordered pair beside each of these angles. Now, the way we're going to do that is by simply thinking a little bit about what do we know. This is called the unit circle. So if it's called the unit circle, that means it is 1 unit in radius. So if it's 1 unit in radius, this ordered pair right here is the ordered pair 1, 0. 1, 0. Which means this ordered pair over here is going to be the ordered pair negative 1, 0. Which means this ordered pair up here is going to be the ordered pair 0, 1. And this ordered pair down here is going to be the ordered pair 0, negative 1. Okay, so everything I've done so far is complete common sense. Okay? However, it's getting kind of full, isn't it? So the last thing I want to add on here is going to be all the ordered pairs for the remaining angles. And those remaining angles are special angles in those three angles in each quadrant. So how do those come to terms? Well, we have to figure out a few things about them. Hypotenuse, opposite, and adjacent. Hypotenuse is the leg of the triangle opposite the 90 degree. It's the longest side, okay? So that is your hypotenuse. Then we have opposite. Opposite is the side directly across from the angle. Well, here's my angle, so this has to be opposite. And then the last one is going to be adjacent, and that is the angle touching it, and that sits beside it, and it is not the hypotenuse. Okay? When you did geometry, you learned a 45 degree 90 triangle. You have this theorem. The hypotenuse is the square root of 2 times as long as each leg. So if I give you this triangle and I go ahead and I put 45 degrees here, that means if I do SOHCAHTOA, if I can spell it, that would be good. If I would do SOHCAHTOA, I can go ahead and I can figure out what this is. Sine is going to be opposite leg over your hypotenuse. And then cosine is going to be your adjacent leg over your hypotenuse. So I want to do what the 45 degrees angle is. I need to do the cosine of 45 degrees, and then I also need to do the sine of 45 degrees. Okay? So the cosine is going to be your adjacent leg over your hypotenuse. So my adjacent leg is going to be this one right here. So that's going to be 1 over the square root of 2. I cannot divide by a radical, so I have to rationalize it. So this gives me the square root of 2 over 2. Now, the sine is going to be the opposite leg over the hypotenuse. So it's going to be the same thing. So what this means is every one of the angles that is a 45 degree angle, This is 45, this is 45, this is 45, and this is 45. How do I know? Look at all the denominators. They all have a denominator of 4. Super important. So what we're going to do is we're going to put that ordered pair, the square root of 2 over 2, square root of 2 over 2, at all the 45-degree angles. But in quad 1, it's plus plus. In quad 2, I have cosine being negative. So this is going to be the square root of 2 over 2, comma, square root of 2 over 2. But the first one is negative because the x represents cosine. Maybe I should put that on here. I have cosine, sine. So that's your ordered pair, cosine, sine. So the cosine is negative in quadrant 2, but the sine is positive. So here's my other angle here. So this is going to be the square root of 2 over 2, negative of that, and negative square root of 2 over 2. Why? Because I'm in quadrant 3. In quadrant 4, I'm going to put the same ordered pair. However, the first one is positive and the second one is going to be negative. So I've done all of my 45 degrees. So now I need to have a 30, 60, 90 triangle. The theorem for the 30, 60, 90 triangle says the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times the shorter leg. So this is what we have going on here. So if I want to do the cosine of 30 degrees, I want the adjacent, which is the square root of 3, over the hypotenuse, which is 2. Then the sine of 30 degrees, that is going to be the opposite leg, which is 1, over the hypotenuse, which is 2. So I'm going to now, for the 30 degrees, everything that has a 30 degrees, which is pi over 6, I'm going to put the ordered pair, square root of 3 over 2, 1/2. So let's go back over to our circle, and I'm going to have, right here, I'm going to have the cosine as the square root of 3 over 2, and the sine is 1/2. Over here, I'm going to have negative square root of 3 over 2, positive 1/2. Over here, I'm going to have negative square root of 3 over 2, negative 1/2. And on this one, I'm going to have positive square root of 3 over 2, negative 1/2. Okay? All of the 30-degree angles are all the ones with a denominator of 6. Super important for you to understand. They hover around the x-axis. Okay? Now, I need to do 60 degrees. So the cosine of 60 degrees is going to be, here's 60. That's going to be opposite. I'm going to have the adjacent leg, which is 1, and then over the hypotenuse 2. Then I'm going to have the sine of 60 degrees. That's going to be opposite, square root of 3, over 2, which is going to be the hypotenuse. So that means the ordered pair that is going to go with the sine values of the 60 degrees, or the 60-degree angles, which has a denominator of 3, is going to be the ordered pair 1/2 square roots of 3 over 2. So I'm going to go back to my circle. And now at the 60 degree, I'm going to type in the ordered pair 1/2 square root of 3 over 2. Over here, negative 1/2 square root of 3 over 2. Down here, this is going to be negative 1/2, negative square roots of 3 over 2. And lastly, this is going to be negative 1/2 square root of 3 over 2. Sorry, I put those opposite. And that is going to be a unit circle. Now, I gave you another one where you could go ahead and try it again. And then I also typed this out for you so that you knew exactly what you needed to have on there and it'd be nice and pretty. This is worth 81 points. And every single thing you need to have on there is exactly what I have on here. Remember, you need to understand that whenever we're doing this, the ordered pairs are going to be cosine, sine. I don't expect you to reproduce the triangles. I just expect you to reproduce the entire unit circle. So in your packet, you will see you have 2 huge unit circles. Those are for you to practice on. If you want to have more of them to practice, please let me know, or just simply print them out here at school or at your home. Okay? If you have any questions, please let me know.